Unit 6.9, factoring polynomials with 4 terms. To solve this, you're basically going to group like terms together and then factor them separately. Alright? Let me show you what I mean. It says it is possible to factor a polynomial with 4 terms by using a method called grouping. Right? Step 1, group the first 2 terms together and the last 2 terms together. So you're going to visually picture these 2 terms separate from these 2 terms. Alright? Now, if I factor just the first group, basically I've created 2 binomials, right? So if I can factor an x squared out, and I'm left with x plus 7, right? And I can factor out a positive 2 from the second binomial, and I'm left with x plus 7. Look at that. Do you see what just happened? You see it? Okay. Factor the common binomial out. You have a common binomial. So I'm going to factor that out, and what I'm left with is x squared plus 2. You can always distribute to double check your answer. Look, x cubed 2x plus 7x squared plus 14. I know, we'll practice. Alright, let's go ahead and distribute it so you can see it. So x cubed plus 7x squared, right? This times this, this times this, this times this. I'm only doing it in that order because I want to be able to write it in order so that it'll be in order. If I did it up, up, and then down, down, they would be out of order, and I would have to rearrange them. But it works either way, as long as they're in order by the time you're done. Alright? So, first, separate them out. Do it, make the line if it helps you see them as 2 groups. They're separate. If it helps you, instead of making the dots, put the parentheses. Basically, you're creating 2 separate groups. Be careful. And the reason they don't use parentheses is because now it looks like you're multiplying, and you don't want to do that. So maybe don't do parentheses. That might trick your mind. Be careful. Right? So, I can take x squared out of this, and if I divide both sides by x squared, right, I'm left with x plus 4. And on this side, I can take an 8 out of both, a positive 8. And if I divide both sides by 8, I'm left with x plus 4. So the common factor is x plus 4. And what's left is x squared plus 8. And that is how you factor with 4 terms. You group like terms together. Just be grateful that they're in order right now, because later they're not going to be in order. You're going to have to figure out what like term goes with what like term. Embrace yourself. Alright? I can take out w squared, and it leaves me with w plus 5. If it's going to work, then this will also leave you with w plus 5. So you can ask yourself, what do I need to multiply these to end up with this? Right? So ask yourself, I can take a negative 8 out of both, and that leaves me with a w plus 5. Right? W plus 5. W squared minus 8. If I was to write this binomial first and this one second, would that be wrong? No. You could write it the other way around. You could write W2 minus 8 and W plus 5. It's still right. All right. The highest is a P, and it's a P3, so I'm going to take P3 out, and it leaves me with P2 minus 6. And then in this one, I can take out a -2. And if I take out a -2, right, I want it to be a -2 because I need this to be -6. If I just took out a 2, it would be +6. I need it to be the same, right? So that leaves me with positive P squared minus 6. Wait, I forgot to write what I took out. I took out a -2, and it leaves me with P squared minus 6. You see why I had to do it by -2? Because I needed this to be -6. Right? So P to the third minus 2 and P to the 2 minus 6. P squared minus 6. You can always redistribute to make sure it works. P to the 5, -6P to the 3, -2P, and then plus 12. 2P squared plus 12. You can always redistribute to make sure you end up where you started. That's how you know you have the right answer. Three x squared, the greatest factor is 3x squared, and that leaves me with x minus 7. And the greatest factor here is 4. And I'm not going to do -4 because I need it to be negative and it's already negative. But if I divide by 4, that leaves me with x minus 7. 3x squared plus 4, x minus 7. You'll notice that I'm intentionally doing it the other way around. I need you to know it goes both ways. Eight a squared, and if I take out an 8a squared, I'm left with 2a plus 1, because anything over itself equals 1. And I could take out a -3. That leaves me with 2a plus 1, because anything over itself is 1. I could take out 4x. Greatest common factor is 4x. And I'm left with 2x plus 3. Greatest common factor here is a positive y. And I'm left with 2x plus 3. 4x plus y. 2x plus 3. And if you ever doubt, redistribute and double check your work. If you ever doubt. A squared is our greatest common factor. And if I take a squared out, I'm left with a plus b. B is our greatest factor. I'm left with a plus b. I'm going to do it the other way this time, just so you can see it. A squared plus b. Order doesn't matter on this case. Because when you redistribute it, you'll get the same answer. Challenge. This time you have to rearrange. Factor each polynomial by rearranging the terms first, then use grouping. This one's going to require some thought, because you're going to actually have to figure out what goes with what. This has an x, an x, an x. This one has a y, and this one has a y. My brain says these two should be together. So let's just rewrite it so they're grouped, right? So these two are going to go together. Negative x squared plus 5x. Then we have our dot to dot, and we've got 2xy minus 10y. You see how it makes sense, how they're grouped together? The only way to find out if I'm right is to solve it and see if we have a common binomial. Alright, so I can factor an x out of both of these. And that leaves me with negative x plus 5. I can factor a 2y out of both of these. And that leaves me with, here's where that question comes in. If we know that we need the signs to be negative and positive, we need to change their signs. Which means we need to take out a negative 2. Right? Because if we divide this by negative 2, negative 2y, we're left with negative x, and if we divide this by negative 2y, we're left with a positive 5. We have to figure out what makes this happen. This is our goal. Right here, this. Matching binomials. This is the goal. Because then if they have matching binomials, you can factor that out. Right? So we can factor that out and then just put what's left in the other parentheses. We need to figure out how to make this happen. Alright, so let's do this one and see if we can figure out the correct order. M, Mn, M, N. These two have M's and these two have N's. 3 and 12 can both be simplified. And 7 and 28 go together. So let's do that, right? So it's 12m squared plus 3m, and then 28mn and 7n. When you're doing this, make sure you're being aware of your positives and negatives, right? This positive sign goes with, this positive sign goes with, this positive sign goes with. If it was a negative, it would go with. It's part of the term. Right? And now let's see if we can create some magic. We can factor out 3m. If I divide by 3m, I'm left with 4m. If I divide by 3m, I'm left with positive 1. I can factor out 7n. So if I take out 7n, I'm left with 4m plus 1. Remember, the goal is to create the common binomial, because then you can factor that out. Factor out the common binomial, put what's left in the parentheses. Good? Alright, so after you've had the practice, go back and do the even numbers. When you're ready for the mastery check, come get it, alright?